Hello students, welcome to the class once again. We have already studied about errors in measurement and measuring instruments. I know that it will be very handy for you all to use now vernier caliper, screw gauge, and you would have solved problems based upon them. Today we'll start the study of kinematics. In this chapter we'll see the study of motion of object without considering the factor which are responsible to give the motion into the object. Before studying, let's study some basic things that is required for this chapter. First of all, let's see distance. What is distance? Suppose you have started from your home and you're going to a school. Let's say this is your home and you are targeting to move to your school. Now, let's say there are three paths while you move from your home to school. This is path 1. Let's say this is path 1. This is path 2. And let's say this is path 3. Now, if you move along path 1, you will cover a different distance. If you move along path 2, you will cover a different distance. If you move along path 3, you will cover a different distance. Now, actually, distance is the measure, or let's say it is the total path length along which you have moved from your initial point to your final point. So, what is distance? It is actually length of path along which the body has moved. Length of path along which body has moved. Now, in this example that I have shown you, you can see here, this will be the distance traveled in the first case. Let's say this is x1, x1 is the distance, and this will be distance traveled in the second case, this will be x2, and let's say this is the total path length of this case is x3. So distance is different along all the three cases. You would be having the idea, and already most of you must be knowing what is distance. Now let's come to the next point. It is displacement. Now we'll go with the initial example to understand displacement. Now again, suppose you have started your motion, you have started the motion from your home to school along any of the three paths. Now displacement is the measure of, it's the measure of minimum distance between the initial point and final point. Here you can see that the minimum will be the straight line that is joining the initial point and final point. So path 2, the length of path 2 will be the displacement. So what it is the minimum separation between initial point and final point, that is a minimum separation between initial and final point. This is known as displacement. Between initial and final point is known as displacement. So it is displacement. In this case, in our example, x2 is the displacement. So I'm mentioning here x2 length is displacement in this case, because this is the minimum displacement that is possible along any of the three paths. Whether you move along path 1 or along path 2 or along path 3, in all the three cases your displacement will be only x2, it won't be x1, x2 or x3. Now you would be having the idea. Let me tell you one more thing. I told you in physical quantities can be classified into scalars and vectors. Let me tell you, distance is a scalar quantity. So you may mention here it's a scalar quantity. That means it has got only magnitude, but it has not any direction. Displacement is a vector quantity. That means it has got both magnitude and direction. How will you find the direction of the displacement? What you do, join the initial point to the final point. The arrow joining, it will be starting from initial point and it will be going till final point. This arrow will be giving you the direction of displacement. So this was basic points about distance and displacement. Let's come to next part, that is position vector. You know, the position of any particle can be given in space in terms of its space coordinates, and that is known as position vector. See what I mean to say here. Let us say any particle is in space in this way. Let's say a particle is present here, okay, and this is the space coordinates that are, this is x-axis, y-axis. Now if we give the position of particle in terms of its x coordinate, y coordinate and z coordinate, let's say x1, y1, z1 are the three coordinates of the position of particle. So if this vector, we join a vector from origin to the point where particle is lying, this vector is known as position vector of the particle, so I mentioned this as position vector. How can you give the value of this position vector? It's very simple. Say that this is r vector and this will be equal to x1 I cap plus y1 j cap plus z1 k cap. This is the position vector of the particle. Now suppose the particle moves from one point to other point. How can we give the displacement in terms of position vector? Let's see here. Now in terms of position vector, in space coordinates, how can we give the displacement of the particle while it is moving in space? That's very simple to understand. What you do, you draw the initial point of particle, let's say it's A here, and let's say after some time it moves to this point B. The coordinates, the space coordinates, or let's say the position vector of point A, it is given as RA, that is equal to x1 I cap plus y1 j cap plus z1 k cap. This is the position vector of particle when it was at point A. Let's say the particle reaches to point B. So this is the position vector of particle when it is at B. Let's say the position vector is given as x2 I cap plus y2 j cap plus z2 k cap. This is the position vector of the particle when it was at point B. Now suppose we are required, what is the displacement? Now see, I told you the displacement is vector quantity whose direction will be the vector, and its initial point should be from the initial point of the particle when it was in the space. So this will be the displacement when the particle has moved from point A to point B. That is, you can give displacement. This will come out to be, you can check from vector law, this will come out to be displacement of the particle will be RB vector minus RA vector, that is the position of the particle when it was at B minus position of the particle when it was at A. Also take down that we are talking about position vector, so we have to mention vector sign over here. So now this will come out to be, as I told you while teaching you subtraction of vectors, this can be very easily written as x2 minus x1 I cap. And if you have practiced questions, problems on vectors, you must be knowing that why we are doing to find out the displacement as RB vector minus RA vector. You can check that. That's very easy to get. Z2 minus Z1 k cap. So in terms of position vector, we got this final displacement. Now let's come to some example based on distance and displacement. Let us say in space a particle starts from origin and it moves from point origin to a point 20, 0. What I mean to say, this is a straight line path that the particle is moving. It starts from origin, and let's say on a straight line it moves from initial point to a point whose coordinates are given as 20, 0. This is the final point. Now it is again saying that the particle turns back, come to its initial point, and further travels ahead to a point minus 20, 0. That is, it turns back and further travels along the same straight line but in opposite direction and moves further ahead, and finally it reaches to a point minus 20, 0. Now along this entire journey, for this entire journey, it has been asked what is the total distance traversed by the body. What is the total distance traversed by the body? Now I told you total distance will be the measure of path length. See, 20 it has moved in the forward direction, 20 it came back, so it will be 40, plus 20 it went to the left, so it will be 60. So this will be equal to 20 plus 20 plus 20, that comes out to be 60 meter. Let's say the units we are going to express that we are going to use, those are given in meters. Now the second part of the question that comes, suppose it has been asked what is the total displacement, or let's say the net displacement. The net displacement of the particle from initial point to final point will come out to be, I told you, it is the minimum separation between initial point and final point. Initial point was this, and finally the particle has reached to this point. This is the final point. So see the path length, this is only 20. So net displacement will be equal to only 20 meter. So you would be having an idea about distance and displacement. Let's come with one more example here we will do. Suppose it's given that a particle randomly is moving in space, and there's a diagram given for you which describes the motion of object, or let's say how an object moves in space. See here, let's say a particle starts from a journey, it starts its journey from point A, it moves, let's say 1 kilometer towards south, reaches point B, further it moves towards right, or let's say towards east, and let's say this is 4 kilometer, and reaches point C, further it moves 5 kilometer towards north, reaches point D, let's say further it travels somewhere around 10 kilometers and reaches point E. In this entire journey, it has been asked what is the total distance traversed by the object and what is the net displacement of the object. So for this example, see what we need to do. Calculate the entire path length, that will be 1 plus 4 5 plus 5 10, 10 plus 10 20. So total distance will come out to be 20 kilometer, because we have used the unit as kilometer, so let's say 20 kilometer. Now suppose it has been asked what is the net displacement. So net displacement will come out to be join the initial point to the final point. This will be the net displacement, let's call it as x. Now see, to evaluate the value of x, this length you can check, it will come out to be 5 minus 1, that will be 4, and this length will be equal to 10 minus 4, that will be equal to 6. Now easily you can evaluate, x will come out to be, that you can use the Pythagoras theorem, displacement x is equal to under root of, you can see it to be 4 square plus 6 square, so 36 plus 16, that will give you under root 52. So now you can easily get, so this will come out to be 2 under root 13, because 13 into 4 will be 52, so you can write 2 under root 13 kilometer. This will be the displacement of the particle from its initial point compared to the final point. So in this way we have the idea about distance and displacement. Remember two more points. Distance is a scalar quantity, it has only magnitude, whereas displacement is a vector quantity, it has got both magnitude as well as direction, and you can easily check the direction. You have to join the initial point to the final point. The vector arrow which is from the initial point to the final point, that is the direction of displacement. Let's come to the next part, that is let's study about the basics of speed and velocity. After understanding this, we can easily understand about speed and velocity. Let us say, first of all I will tell you what is speed. We all know that, you all must be knowing about speed. Speed is the rate of change of distance with time, or I'm writing it's rate of change of distance. When we use the term rate, that already means time is already involved. So it's rate of change of distance. This is given as speed. Now suppose you want to find out the average speed when the particle is moving. Let us say particle started from point A, it reached point B, okay. The separation between the 2 points is given as s, and during its journey it took time t for it to move. So speed will be given as, that's very simple, speed I am using with the letter u, that will be equal to distance by time, and which will be given as distance by time, this will be equal to s by t. This is very simple formula. Now even we can write this as average speed, because we are talking about the total distance traversed. So we can write average speed term, this will come out to be total distance traversed upon total time, total distance upon total time. So it doesn't matter whether the speed is varying or whether speed is uniform, it doesn't matter. You have to check the total distance upon total time. And yes, if the speed is uniform, then you will see that with whatever speed you are moving, the same speed will come out to be the average speed. We'll do problems on that, we'll check that. Now see, how can you see the instantaneous speed? Means when I say the term instantaneous speed, I'm talking about the speed at that particular moment of time. Suppose you are moving in your car, you can observe the speedometer. Speedometer gives you the speed at that particular moment of time, okay. Now let's let's do a very simple problem. Let us say a particle is moving with variable speed, and during its course of journey it has moved with a speed v1 for time t1, v2 for time t2, and v3 for time t3, and so on. The example is a particle is moving with a speed for time t1, is moving with a speed for time t1 with a speed v1 for time t1, v2 for time t2, and v3 for time t3, and so on. So now you can understand up till, let's say, vn for time tn. Okay, now it has been asked what is the average speed of the particle during its course of journey. So find average speed. This is the problem. Find the average speed. That's very easy to evaluate. Just now I told you average speed. Average speed is what? Average speed is total distance traversed upon total time taken. So total distance will be what? Total distance will be v1 into t1 plus v2 into t2, and so on. So I'm writing s1 plus s2 plus s3 and so on up till sn. This is the total distance traversed upon total time. So t1 plus t2 plus t3 and so on up till tn. Now this will come out to be s1, we can write in terms of v1 and t1, that is v1 into t1 plus v2 into t2 and so on, vn into tn upon t1 plus t2 plus so on up till tn. Now this is the answer for average speed that we can see. Let's say this is average speed, u average. Now suppose in this case it's given that, one more key point, let us say if let's say t1 is equal to t2 is equal to, let's say, some time t is equal to some time t. Let's say t1 is equal to t2 and so some time t. So what you can see, we can write that we can replace t1, t2, t3 up till tn with a uniform value, that is t. So we will be getting average speed as v1 and t1, that t we can take constant, t v1 plus v2 up till so on. This will be vn upon, let's say there are n intervals, so n into t, tt will be cancelled out. You can make it very simple, v1 plus v2 up till vn divided by n. So what we are finding, if for a fixed time period a body moves with a certain speed, and for the another fixed time it moves with a different speed, if you want to find the average speed, you will just simply add all the speed and divide by the number of time interval. One more example to understand it. Suppose it is given that a body during its course of journey moves with speed v1 for the first half of time and moves with speed v2 for the second half of time. We have to find out what is the average speed. A body moves with speed v1 for first half of time. In short, I am writing that you may understand, for first half of time, and let's say it has moved v2 with speed v2 for the second half of time. When we use half, that means let's say that t half of the course of journey, during the course of journey it took t plus t 2t time. So the first half time I am writing as t, the second half time as t. So if the question comes, what is the average speed? Just now I told you, when the time period is uniform, so average speed will come out to be v1 plus v2 by 2. v1 plus v2 by 2, this will be the average speed in this case. Now let's say if the question is given in this way, that the body travels with the 1/3 for its journey with the speed for time t for the 1/3 of its journey, and then again with some speed v2 for again in the next 1/3 of the journey, and with speed v3 for the again next 1/3 of the journey, the speed will be simply the uniform, the average speed will be v1 plus v2 plus v3 divided by 3. You will be having, you can easily calculate the average speed. Let's come to the next part. Suppose this was about speed. Let's talk about velocity. Now speed is also a scalar quantity. Now let's talk about velocity. Now velocity is nothing, it is related to speed, or the only thing that it has got direction. It has got direction. Now velocity is actually rate of change of displacement. This is rate of change of displacement, and whenever I am using the term rate, that means already time is included in it. Rate of change of displacement. See how we can write? We can write V is equal to, or I will start with mentioning average velocity. Average velocity. Average velocity can be written as V is equal to net displacement upon total time taken. This is the average velocity, net displacement upon total time taken. Now velocity has got direction, because we are talking about displacement, that means velocity will also be having a direction. The direction of average velocity will be the direction of total displacement. Now suppose it has been asked what is the instantaneous velocity. The instantaneous velocity is the velocity at that particular instant of time, and its direction will be the change in displacement at that particular instant of time. For example, first let me mention instantaneous velocity. See how can this be written? Instantaneous velocity is nothing but actually when you are recording the velocity at a particular instant of time, this will come out to be V instant. If you know, I told you, when we are measuring a change with respect to time, we can depict that change at that particular moment as differential value. So we are writing dx by dt. This will give me the instantaneous velocity at that particular instant of time, and its direction will be, just check the change in displacement direction at that particular instant of time. Example, let's talk about example. How can you see the direction of velocity? Suppose we are referring to certain kinds of motion. Suppose let's start with very simple straight line motion. A body, let's say it's moving along a straight line, okay? So at any instant, its change in displacement direction, you see, let's say body's point here when it was at some instant of time, after some time it reached to this second point. So the change in displacement direction will be also along the same straight line. So the change of the velocity, the instantaneous velocity, will be along this same straight line. Now suppose you have taken a stone, let's say we have taken this stone and I throw it. It will move and it will come again in my own hand. You see, I throw it, it moved along a parabolic path, it came in my hand. We will study this also, but see what I want to show you here, how its path will look like. If I throw it, it will move somewhat like this along a parabolic path. Its velocity, you can see it's changing everywhere. You see, the velocity at this instant of time will be given along this direction. At this instant of time, it will be along this direction. At this instant of time, it will be along this direction. So by this, we have to check at that particular instant of time, what is the direction of change in displacement that will give me the velocity at that particular instant of time. So I'm marking this as V1, I'm marking this as V2, I'm marking this as V3. So for now you can see at every instant the velocity is changing. You can see some more example. If we talk about a circular motion, in this case, a circular motion case, the velocity will change at every instant, although the speed might remain same everywhere. Let's talk about uniform circular motion. When the body is moving with the same speed in a circle, we will see that speed may remain same, but velocity will change. Here, let's say at this point, the velocity is V1. At this point, velocity is somewhat V2. At this point, it is V3. At this point, it is V4. Although the magnitude of velocity may remain the same in all the four cases, but you see, it also depends on direction. So we will say the velocity is changing at all instants of time, since the path of the motion is changing. So velocity is dependent on direction. So therefore, it is a variable velocity case. Let's come to the next part. That is, we talked about speed, we talked about velocity. Now one more part we can add. that is the acceleration. Acceleration, already you must be knowing the idea about acceleration. Acceleration is nothing actually, it is the rate of change of velocity with time. So that is, it is rate of change of velocity. This is acceleration, rate of change of velocity. Now, you all must have learned about acceleration in your junior classes. So whenever a body is accelerated, its velocity will change. Now, we cannot say whenever an acceleration is acting, the velocity will always increase. There might be cases when the acceleration is acting, but still the velocity magnitude may not change. But yes, velocity will definitely change, but its magnitude may not change. In uniform circular motion, we will see that the velocity magnitude may remain the same, but yet acceleration is acting on the body. Now, whenever the acceleration, let's say a uniform acceleration is acting on a body, there are two kinds of path that is possible for uniformly accelerated motion. For uniformly accelerated motion, two kinds of path are possible. You should note this point especially. For uniformly accelerated motion, path possible, two types of path are possible. Those are two types of path are possible. These are given as. Now see, in general, whenever I say you a body is uniformly accelerated, the first idea that will be coming in your mind, yes, it will be following a straight line path. And okay, that's very obvious. But now I will tell you one more thing in where the path is a parabolic path. The body is going through a parabolic path. The first one is a straight line path, which is very simple for you all to think and imagine. The straight line path. This is the body, it's moving, and let's say acceleration is acting on it. Okay, so hence the body is following a straight line path. Now suppose if again take this object, if I throw it, the only acceleration acting on it is the acceleration due to gravity, and that is downward. You can see this is moving, but again the velocity is changing. Although acceleration, uniform acceleration is acting on it, yet the path is not straight line, it's a parabolic path. So second, a parabolic path is also possible in a uniformly accelerated motion case. The example I believe that you all can see here, if a body is moving under acceleration due to gravity, you see here uniform acceleration, G is regularly acting on the object, yet the path of the object is parabolic. Hence, the object can move along two kinds of path, that is straight line path and parabolic path, whenever uniform acceleration is acting on the object. Now, let's see some formula related to acceleration. Now, acceleration is also of two types, an average acceleration and instantaneous acceleration. The average acceleration is given as average acceleration. This is actually net change in velocity upon time taken. Net change in velocity upon time taken. This is net change in velocity, or we will mention in this way, V2 minus V1 or V final minus V initial upon total time taken, that is T. This is the value of average acceleration. And if we talk about instantaneous acceleration, now when I'm using the term instantaneous acceleration, we are talking about instantaneous acceleration. Instantaneous acceleration. In this term, we mean that we are checking the acceleration at that particular instant of time, and this can be given as, let's say this is A, this will be given as change in velocity at that particular instant of time, that is A is equal to dv by dt. Let's do some examples so that we may have a better understanding of this. Let's say a body started its motion with the speed 20 meters per second, and finally when it reached to its final point, its velocity was 60 meters per second. During its course of journey, let's say it took a time of nearly 20 seconds. What is the acceleration? So very simple example we are going to start. Body started with a velocity of 20 meters per second, and when it completed its journey, its final velocity was 60 meter per second, and during its course of journey, it took a time of 20 seconds. So what is the total average acceleration of the body? The average acceleration will be given as average acceleration is equal to change in velocity v final minus v initial upon total time taken, that is 20. So this will come out to be 60 minus 20 upon 20, that is 40 by 20. This will come out to be 2 meter per square second. So we got that a is equals to 2 meter per square second. Remember, this is the average acceleration. Now, how to find out the direction of average acceleration? What you do, you should know the final velocity direction, you should know the initial velocity direction, and then you have to subtract final velocity minus initial velocity vectorially. That will give you the direction of average acceleration. Now suppose, let's do an example of instantaneous acceleration. Instantaneous acceleration. This is also not too tough to solve questions based upon it. Suppose it's given that velocity of an object is depending on time with the equation, let's say 3t square plus 2t plus 5. This is the how velocity is varying with time. Suppose it has been asked what is the acceleration of the object at t equals to 2 seconds. Let us say find acceleration of object at t equals to 2 seconds. So find acceleration of object at t equals to 2 seconds. This is what we are interested to evaluate. Now what we need to do? We have to find the instantaneous acceleration at time t equals to 2 seconds. So just take this equation, differentiate velocity with respect to time. See what we are going to get. dv by dt will be given as 60 plus 2, and constant differentiation is 0. So we got this. So this is the value of acceleration. Now suppose suppose we want to find the acceleration. So acceleration at t equals to 2 seconds. Substitute the value of t equals to 2 seconds in this equation. We will get a equals to 6 into 2, 12 plus 2, that is 14, and let's say the units are given in meter and seconds, so it will be meter per square second. One more thing you can learn, that the unit of acceleration is meter per square second. That is not too tough to understand. One more example to have an understanding of displacement, velocity and acceleration. Let us say displacement of an object is dependent on time, and that is given as s is equal to 4t cube plus 2t square plus 3t plus 4, let's say. So it's required, find the total displacement from time t equals to 0 to time t equals to 2 seconds. So it's required, find total displacement, find, first question, total displacement from time t equals to 0 to t equals to, from t equals to 0 to t equals to, let's say, 2 seconds. It's required. First part of the question. Let's solve this. See what we will be getting. Find total displacement from t equals to 0 to t equals to 2 seconds. At t equals to 0, you will see s will come out to be 0, 0, 0 as 4 meter. At t equals to 2 seconds, if you substitute the value of t equals to 2 here in the given equation, we'll be getting s is equal to 4 2 cube plus 2 2 square plus 3 into 2 plus 4. Now this will be the value of the final displacement, and that we are going to see at t equals to 2 seconds. 2 cube is 8, 8 into 4, 32, plus 2 cube is 2 square is 4, and here we have to multiply with 2. So you will be getting 4 into 2 as 8, and 3 into 2 as 6 plus 4. 32 plus 8, 40, 40 plus 6, that's 46 plus 4, 50 meter. So we got here as 50 meter. So now net displacement from t equals to 0 to t equals to 2 seconds. So net displacement will come out to be, I believe that you all can see here. Net displacement will come out to be is equal to 50 minus 4, that is 46 meter. This is the value of net displacement. Now, let's come to the next part of the question. Suppose the second part is also find, I believe that it is visible simultaneously as I write here. Second part, find instantaneous velocity or find velocity at t equals to 2 seconds. Find velocity at t equals to 2 seconds. Now to find this what we need to do, differentiate this given equation, differentiate the given equation with respect to time. You will get v equals to ds by dt, and as we differentiate we'll be getting 4 into 3, 12 t square plus 2 into 2, 4t plus 3. This is the differential value. So at t equals to 2 seconds, now substitute the value of t equals to 2 here, you will be getting v equals to 12 2 square plus 4 into 2 plus 3. 2 square is 4 and 4 into 12, that will give you 48 plus 4 into 8 plus 3. 48 plus 8, that gives you 56 plus 3, that will give you 59 meter per second. And this is the speed, this is the velocity at t time t equals to 2 seconds. Now suppose you are required also find the value of acceleration at t equals to 2 seconds. So let's do here. I'm rubbing this part, keeping the equation as it is. Suppose it's required also find the value of acceleration at t equals to 2 seconds. So at t equals to 2 seconds, we have to find the acceleration. So double differentiate this, or you can differentiate this equation. So this equation, when you differentiate, acceleration is dv by dt, and as we differentiate, we'll be getting 12 into 2, 24t plus 4. This is the value. So at t equals to 2, see what we will getting. A will come out to be 24 multiplied by 2 plus 4, 48 plus 4, that is 52 meter per square second. So this is the value of acceleration at t equals to 2 seconds. Now with all this, now I believe that you will be having the idea how to take the differential coefficient and how to find out the instantaneous velocity and instantaneous acceleration. One simple formula will give you the relation between acceleration, velocity and displacement. See here, already I have told you about differentiation, I have taught you, and you will be knowing about it. Now today you learnt about that v is given as rate of change of displacement, so v is equal to ds by dt, and I told you acceleration is rate of change of velocity, so a is equal to dv by dt. Now here I can write, you see here, we can write this as a is equal to, if we divide here by dx and multiply by dx, so we are writing this as dx, or use s and multiply here ds by dt. Okay, now see, ds by dt is v, so what we will do, keep here this as dv by ds and this as v. Here we got a. Now take ds to the left hand side, you will get a ds is equal to v dv. This is one equation which will be very helpful for relating acceleration, displacement and velocity. You can also write the same thing as v dv is equal to a ds. That won't make any big difference. v dv is equal to a ds. This relation also, the same relation can be written in this form also. This gives us the relation between velocity, displacement and acceleration. These were all the basic points about acceleration, speed, velocity and displacement. And after this class, I believe you will be practicing questions based upon all this. And after this class, in the next lecture, we'll study about equations of motion. We'll see the graphical representation of motion. Now after this, we'll practice more problems on motion. Till the time, what you do, just revise this class, see what is distance, displacement, practice problems from your textbooks, see what is acceleration. When you practice problems when the acceleration is given in terms of equation or velocity given in terms of equation, you will be having a better understanding how to find the instantaneous velocity or displacement. We will start from here onwards in the next class. Till the time, do learn physics, do enjoy learning physics, take good care of yourself. This is Abhinav signing off. Thank you everyone.